Okay, so in this video I'm going to combine everything that we've done so far and I'm going to combine it with surds. If you haven't done surds yet, I would definitely go and review that playlist before you try these questions. So it says work out the following, leaving your answer as a surd in its simplest form. So we have 12 to the power of 5 over 2. Well, we know that the 2 is going to be doing the square root, and then that's just going to be the power of 5. So it's 12 to the power of a half, which is the square root. So I'm just actually going to go straight in and just say it's the square root of 12, and that's the square root of 12 to the power of 5. Now the best thing to do here is to simplify any surds as you go. So simplify any surds as you go. Now hopefully you can remember that square root of 12 can be written as the square root of 4 times the square root of 3, which is just 2 root 3. So actually I can replace this with 2 root 3 to the power of 5. Let's just think about what this means before seeing if we can spot a shortcut. This is 2 root 3 multiplied by 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 2 root 3. So it looks like, because it's the power of 5, we're going to have 2 to the power of 5, and 2 to the power of 5 is 32. And then we want to think of what's happening here. So this root 3 and this root 3 is going to be multiplying to a 3. We've got another two things multiplying together, which is going to be another 3. And then we've got one final root 3 at the end, which is just going to have to stay as a surd. So all we need to do is do 32 times 3 times 3 times root 3. So I'm going to be a bit lazy. I'm going to do 32 times 3 times 3. So it's 288 root 3. That is our answer as a simplified surd. Let's see if we get the same answer when we do it as 12 to the power of 5 over 2. We do get 288 root 3. Now I guess the shortcut, what you could do here is you could say this is going to be 2 to the power of 5 and then root 3 to the power of 5. The root 3 to the power of 5 there, you've got to think that 2 root 3's create a 3. So you actually get a 3 squared and then this extra root 3 at the end. So there are other ways of doing this. This is just the way I like to think about it with writing it out, but you might spot some other shortcuts when you're practicing these questions. So 18 to the power of 3 over 2. Well, the bottom part is going to be doing the square root and the top part is going to be doing the cubing. So we're going to do the square root of 18 and that is going to be cubed. Now, like I said, simplify any surds as you go. So the square root of 18 can be simplified as root 9 times root 2, which is just 3 root 2. So it is 3 root 2 cubed. Well, let's try the shortcut. 3 cubed is going to be 27, and then we need to think of what root 2 cubed is. It's root 2 times root 2 times root 2. Well, two of them create a 2, and we also have an extra root 2 left over. So you get 54 root 2. I guess you could also think that 2 to the power, if we're trying to do this cubed, is 2 to the power of a half cubed, which is, you could switch the order. It's 2 cubed to the power of a half. So it's 8 to the power of a half, or the square root of 8, and the square root of 8 is 2 root 2. I don't know, there's lots of different ways of doing this. I think probably the first way I did it was better. Maybe I've got a bit more confusing as I've gone. So I want you to try this one here in your turn. Pause the video and have a go. Okay, so it's going to be, from the denominator part, it's going to be the square root of 50, all cubed. Now the square root of 50 is the square root of 25 times the square root of 2, so it's just 5 root 2. So it's going to be 5 root 2, all cubed. Think about what that looks like. So 5 root 2 times a 5 root 2 times a 5 root 2. 5 times 5 times 5, 125. Root 2 times root 2, one of those pairs is going to give you a 2, and you've still got a root 2 left over at the end. So you get 250, 125 times 2, 250 root 2 for that. Now I'm going to stick with this on this one video. I've got a very challenging question here. I want to try and evaluate 0.05 to the power of 1.5, leaving your answer in the form root A over B. Now let's try this. So we don't like the fact that things are in decimals for this topic, so we're going to try and change everything from decimals to fractions. This is a really tricky question, so we're going to go from decimals to fractions. Now 0.05 is 5 over 100. You could think of it as 5 hundredths, or you might just know that it is 1 over 20. And obviously 1.5, which is the power, is the same as 3 over 2. So 0.05 to the power of 1.5 is 1 over 20 to the power of 3 over 2. Well, the 2 is going to be doing the square root. So I'll do the square root of 1 and the square root of 20, and that is all going to be cubed. Well, the square root of 1 is just, the square root of 1 is 1. The square root of 20, I think we can simplify. The square root of 20, that's root 4 times root 5. Root 4 is 2. So when you simplify that surd, you get 2 root 5. So it is 1 over 2 root 5, all cubed. Now, this is where you have a chance. You can either take this and you can rationalize the denominator and then cube it, or you can cube it and then rationalize the denominator. I don't really mind which one we do. I'm probably going to cube it first. No, I'm going to rationalize the denominator first and then we'll cube it. So somewhere else on the page, I've got 1 over 2 root 5. If I want to rationalize this denominator, I'm going to multiply the top and bottom by root 5. You need to recap surds if you're not sure what I'm talking about here. 1 times root 5 is root 5, and 2 times root 5 times root 5 is 2 times 5, which is 10. So I'll just show you that that works on the calculator. 1 over 2 root 5. I think this calculator rationalizes, maybe it doesn't. This one doesn't rationalize, but it should rationalize to root 5 over 10. I always forget my calculator doesn't do that. So this is the square root of 5 over 10, all cubed. So let's deal with the bottom part cubed. 10 cubed is 1,000. Now root 5 cubed is root 5 times root 5 times root 5. Root 5 times root 5 times root 5, well, root 5 times root 5 is 5, so you get 5 root 5 over 1,000. All that's left to do now is to simplify this fraction, because this part, the 5 and the 1,000, can be simplified like a normal fraction. So I can divide the top by 5, and I can do the bottom divided by 5 as well. And 1,000 divided by 5 is 200. So the answer, what the form is of A and B, A is equal to 5, and B is equal to 200. Let's see if the calculator gives us this. My calculator with surds sometimes behaves a little bit differently, but if I do 0.05 to the power of 1.5, I've got 1 over 40 root 5, and 1 over 40 root 5 actually is the same answer. Let's just see it as a decimal. So we've got this one, and we just said that it was going to be root 5 over 200. So let's see that we get the same thing. Yep, my calculator doesn't show things in the correct surd form sometimes, but you can see that these answers are identical to each other. So a very, very tricky question that pulls in indices with fractions as well as surds as well. In the next video, we're going to be going back to the index laws, but this time with algebra instead of numbers. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.